Today we're going to talk about lesson 3-4, solving ax plus b equals c problems. If you remember from previous sections, when we had an equation, ax plus b equals c equation, we would put this in for our y1, the left side of the equation for our y1. We would put this in as our y2, and we could either use the table, so on and so forth, to find the answer, or what we could do is we could have our graph to help us find the answer of where they intersect at. What these problems are called in algebra are two-step problems. It says these equations of the form ax plus b equals c can be solved in two major steps using your inverse operations. So, example 1 says solve a negative 3 halves x minus 53 equals 7. First thing we got to find out, where's our variable at? Well, our variable is over here on this left side. So everything but this x has to get moved over to the right. Okay? So we got to use our inverse operations. The inverse of addition is subtraction. The inverse of subtraction is addition. Inverse of multiplication is division. Inverse of division is multiplication. So the first thing you got to do is you have to add or subtract first. We work backwards in algebra. So if you look here, am I subtracting anything? Well, I'm adding or subtracting 53. Here I am subtracting 53. So the inverse of subtracting 53 is adding 53. Whatever I do to the left side, I have to do to the right side. My 53s are going to add out, and it's going to leave me a negative 3 halves x equals 7 plus 53 is 60. Now, this says a negative 3 halves times x. Well, Mr. Johnson has told you before, if you have a fraction, to get rid of this fraction, all you have to do is multiply by its reciprocal. The reciprocal of a negative 3 halves is a negative 2/3. All you have to do is flip these over. Numerator to the denominator, denominator to the numerator. That's our reciprocal. Signs stay the same. Why do signs stay the same? Well, we want a negative times a negative to give us a positive, because when we divide these out, it's all going to be left with a positive 1x. Now, as I said before, whatever I multiply over here, I have to multiply by over here. I multiplied on the left-hand side by a negative 2/3. So I need to do the same thing over here. To make your multiplication easier, notice how I put 60 over 1. So I have a fraction times a fraction. Now, whichever way you want to do it's fine. You could go 60 times a negative 2 gives you a negative 120. Negative 120 divided by 3 gives you a negative 40, correct? Or what you could do is say 3 goes into 60 20 times. 20 times a negative 2 is a negative 40. Either way is fine. You're going to get your answer. Now, how do we know if we're correct? Well, you could go right back up here, negative 3 halves times x. What's my x now? My x is now a negative 40 over 1. Minus 53 has to give me 7. Okay? Let's see if this works. 2 goes into negative 40, a negative 20 times. A negative 3 times a negative 20 is a positive 60. Minus 53, does that equal 7? Yes, that works. So negative 40 is the solution to my problem. Example 2 says, when Val works at the zoo on Saturday, she earns $10.80 per hour. She is also paid $8 for meals and $3 for transportation. last Saturday she received $83.90. So she's getting paid $10.80 per hour. Okay, $10.80 per hour. So that's going to be my X. I don't know how many hours she worked. That's our question. How many hours did she work? X equals number of hours worked. Plus she gets paid for meals, so she got paid $8 for that. And she got paid $3 for transportation. That all has to equal a total of $83.90. Okay? Now, we can combine like terms. 8 and 3 are like terms, so we can say 8 plus 3 is 11, which then turns this into our two-step algebra problem. Okay? We got to add or subtract first. So the inverse of adding 11 is subtracting 11. Whatever I do to one side, I have to do to the other side. Leaves me with 10.80x is equal to, and remember these are decimal points, it's $11, so that still is 90 cents. 3 minus 1 is 2. 8 minus 1 is 7. Okay? The inverse of multiplying by $10.80 is dividing by $10.80. So I divide here. These will divide out, leaves me with X. So get on your handy dandy calculator, $72.90 divided by 10.8 equals, she worked 6 3/4 hours. Not too bad for all in a day's work. Correct? $72 a day, not too bad. Okay? Moving along. Example 3 says the area of the largest rectangle is 94 centimeters. What is the value of n? Okay. So in order to find the area of the largest square, that's what we're looking for. Area, of the largest rectangle. Large rectangle. We have to take area of the blue plus area of the white. Everybody see how I wrote that? So to get the large rectangle, we have to find the area of the blue plus the area of the white. Okay? So area of large, we know equals what? Well, it says the area of the large rectangle is 94 square centimeters. So area of the large rectangle is 94. Equals, what's the area of the blue? Well, area of the blue is length times width. What's length times width? Well, 3 times 4 is 12, right? And we'll get to that in a little bit. Area of the white. Area of the white is length, which is n plus 10, times my width. Well, what's my width here? What's this distance? Well, that distance is 4. Looks like a distributive property here, right? To get rid of the parentheses, 3 times 4 is 12. 4 times n is 4n. 4 times 10 is 40. If you look on my right-hand side now, I have like terms, 40 and 12. 40 plus 12 is 52. Now this time my variable is on the right side. Okay? So I got to get the 52 over there. I got to get the 4 over there. So the inverse of adding 52, that's the sign in front, that's an imaginary plus, is subtracting 52. Whatever I do to one side, I have to do to the other. 94 minus 52, 4 minus 2 is 2, 9 minus 5 is 4, equals 4n. The inverse of multiplying by 4, dividing by 4, n is going to equal 42 divided by 4 is, anybody know? 10 and a half, right? And this is centimeters. So if we were trying to find the, well, we found the value of n, right? If we were trying to find the value of this whole side right here, you put 10 and a half in for n. 10 and a half plus 10 is 22.5 centimeters is the distance from here to here. Okay? Moving along. Variations of ax plus b is equal to c. If an equation has a variable on the right side, as in c equals ax plus b, the solution can still be obtained by adding the opposite of b and multiplying by the reciprocal of a. The commutative property of addition also implies that ax plus b equals c is equivalent to b plus ax is equal to c. For example, the following equations can be solved the same way. I want you to look at these because this is what confuses a lot of people. These are all the same problems, it's just written in a different way. To solve this problem, I would add 53, multiply by 2/3. Same way here. The inverse of subtracting 53 is adding 53, multiply by 2/3. Here, inverse of subtracting 53, adding 53, multiply by 2/3. Same thing here. Although these are all written differently, the steps are the same. You have to recognize where your variables are at and what steps you need to take to get everything over to the other side. Please pay attention to this. It's very important. A lot of people have a tendency of doing two operations on the same side and then getting it mixed up. If you write your problem just as Mr. Johnson did, ax plus b is equal to c, and you show I subtract b, left side, right side, so on and so forth, you will be successful in finding your answer. And as you can see, we can even do it with variables. Thank you very much. Have a good day.